GM, everybody. My name's Ellis. I am the founder of Cracked Labs, and we are super excited to be hosting the Aptos AI Agent Thunderdome AI Agent Hackathon. That is where all agents are coming on chain and getting badass. We are kicking off the webinar series with Marlin Protocol. Today we have Pratik joining us. Pratik's one of the lead analysts. Pratik, I'll let you introduce yourself, and we'll kick it off from here. So everybody enjoy. Expect a good one this morning. Pratik?
Yeah, thanks, Ellis. So I'm Pratik. I'm a researcher at Marlin Protocol. And yeah, I've been in the space for a long time, mainly as a researcher, protocol designer, and Web3 developer. And yeah, today I'm here to give a workshop related to how you can deploy agents using teams, and why do you even have to do that, and how does TEs help with that. Alex, can you pull the slides up? Yeah, thanks. Okay, so let's start. Yeah, so So as I think you guys have already seen, and as we are observing, AI agents are everywhere. They are essentially basically doing a lot of things, and they're probably pretty integral to Web3. They're not just tools; they are they are powerful on ramps. They like Yeah, the moment you can simplify complex tasks, and one of the reasons why the adoption of Web3 has been a bit on the lower side is because of the adoption, and that's one of the reasons is the complexity. Or it's very different from what Web2 folks are used to. But AI agents can actually help simplify these tasks and abstract out everything, and make it really seamless for the new users. So yeah, we see AI agents as a powerful tool in enabling the next million users. So yeah, with that, let's kick off with why do we even need these AI agents? I think that why do we need AI agents is already pretty clear, and that's what I've been talking about. And now let's move to how are AI agents working today, right? Um, so there are like multiple AI agents. Some basically read news sentiment and based on the do trades on your behalf. Some some basically help you out with executing your intent even when you're offline. Let's say if if a war starts somewhere in the world, then probably uh, dump my tokens. Maybe that's what your intent, and you are fast asleep, and you want these instructions to be carried out even when you are offline. Um, so these are things which AI agents can do based on your instructions. And we already see a lot of sniper bots who are reacting to token listings on our tweets from basically tweets based on what's happening in the world and how that might affect markets. And these are like way faster than us humans reading this and actually doing it. So yeah, so I think there are already AI agents which are being used, and there are like others like airdrop claimers and things like that, which parse all the project info and then automatically claim rewards if they are eligible. And these are just some examples, but AI agents can deliver unmatched convenience and by automating all these. Now let's come to the main question here. Sure, we have these agents which can do a lot of stuff, and then there's a lot of potential, of course. But do they actually can we actually trust them? What I mean by that is, of course, you have to for these AI agents to be able to execute all these things. We have to give our keys, or we need to give access to our funds, and we need to be sure that the logic which is encoded, or which they are supposed to be following, is actually being followed, right? Uh, and now today, I think it's mostly trust me, bro. I guess it's like basically you trust the developers, or whoever is actually building these AI agents to actually build it correctly and not have any backdoors, and there's no way you can actually verify them, right? Uh, and you also have to give your private key or access to your funds, and you're essentially blindly trusting these devs or apps to behave correctly, right? Which isn't great, which is something we probably don't want to do, at least in this space, I guess. So, but yeah, but that's a start. But how do we go further and actually make these things useful and practical for people to start using? So that's where, to achieve these things, what do we need? Like, we need to be able to prove that the code which is running, the code to which you gave access to your keys or funds, is actually running correctly, and it's not being tampered with, and the keys aren't exposed to anyone, right? These are various things which you want to do, right? You need guarantees, and let's say um, I tell you that we can do all these things. We can run your agent without ever giving your keys to anyone. We can cryptographically verify that your agent only does what it's supposed to do, nothing more, nothing less. And what if we could do this without trusting anonymous developers or admins of the servers where these agents actually run? Right. So this is so to achieve these goals, we need an environment which can provide confidentiality, which can also provide integrity. Right. So this is where TE is coming. Um, just a second. Yeah. So this is where TE is coming. TEs essentially are secure zones within your computer, and they allow code to be run in an isolated way. And these, by isolated, I mean not even the host operating system with admin access can they can't even access these zones. And like, think of it as a black box where you give some inputs, and these inputs include your code. And this black box, no one can peep into it, or they can't modify it, right? So and this black box does whatever computation which needs to be done based on the inputs it's given, and it produces outputs while not exposing any of the internal state, right? So that uh, this is exactly what TEs do. They provide you this confidential environment, and they also maintain integrity of the code which is running within them. And they are isolated from rest of the hardware, so that any so that like the having so that the admin of the host machine can't really make any changes or manipulate in any way the code which is running within, right? So yeah, these are the guarantees which TVs provide. And there is one other thing. There's a proof. There's that this is happening correctly. That's called remote attestation. It basically says that yeah, this particular TE is actually running the code with these measurements. You can assume they are hashes. So basically, this is the code, the hash of the code which is being run within the machine, and it hasn't been tampered with. Uh, This combined with the guarantees which TEs provide, this can ensure that you can prove that something is running within a TE and it is doing what it is expected to do, and it is can't be accessed by anyone else. Uh, so that's essentially what TEs provide. And Marlin provides a confidential VM, which is powered by TEs. So we use Nitro enclaves, and so you can load any AI agent into the TE, and once it's loaded into the machine, it can't be tampered with. And the host machine, which is running this TE, also can't make any changes to the code which is run within a TE. And there are attestations provided which prove that the code is actually running correctly. And any changes, like if let's say the host machine stops it and starts it again, then the attestation changes as well, which ensures that there's no way someone can cheat the users and run a different code. And what Marlin provides is a layer on top of the TEs, which like TEs are hard to work with in general, but what Marlin does is abstracts out all the complexity which is involved in running programs on TEs, and we replaced it with a Docker based interface. So essentially, all you have to do to run your agent within a TE is build a Docker image of your agent or a Docker Compose file for your agent and all the services you want to run within a TE. And that's about it. Once you have this Docker Compose, you can just deploy it, and the machine, the agent is actually hosted within a TE, and you get all the guarantees which TEs provide you. And this one's pretty similar to how you run your program within a VM. So you, with all this abstraction and simplification of interfaces, what we provide users is an easy way, as easy as you deploying it on a VM. To In a very similar way, you can just run it within a TE, and the keys which are basically we are geared towards we provide a lot of features which are geared towards web3 environments. So the secure key handling is provided out of the box. uh, I'll probably come to multiple types of keys and how you can use them and all that throughout this workshop. um, yeah, that's essentially an overview of what we provide. Um, okay, now let's start with something with an example, right? So let's probably dig deep into this example and understand what are the problems, what are the problems if you run it without a TE, and how can TEs help, and how does your agent look like in such scenarios, right? So the agent, let's assume this is a wallet agent which can rebalance your portfolios, which can claim airdrops, which can do trades based on certain rules, right? Now, if you run it without a TE, as I mentioned before as well, you give it your private key, you can't prove what's running, you just trust that you gave keys to a code which is hopefully running fine, uh, which is not great. So the okay, yeah. So with TEs, what you get is that you get your code. So this is actually let's step back a bit. Uh, the example currently just has all the public things, like essentially rebalancing portfolios, claim airdrops. All these rules, let's say, are public. In even in that case, basically what TEs provide is that code is can be verified through attestations. Essentially, you can prove to anyone as an app developer. If I deploy the TE, then I can prove to the user that the code which is running within the TE doesn't like it's is the same code which is expected to run, and it is the same code which is on probably my GitHub, and it isn't anything different, and there aren't any backdoors, like, and the code is exactly same, right? And that's one of the things which I can think. The other thing which I can prove is that the secrets, let's say if user once the TE is deployed, if user wants to share a key which has access to funds, let's say, right? So in such cases, you can prove to the user that you can basically enable users to securely share these keys with the TE, and the TE, and once shared, these keys don't leave the TE, and they run like they are used as per the code which we are providing attestations for. So this provides enough guarantees for the user to like to basically run to share their keys without worrying a lot about what if the let's say the dev team rug pulls, what happens to my funds, these kind of things, like user doesn't need to worry about, because TE provides all these guarantees as long as the code doesn't have any bugs itself. So basically, once the code is verified, you can ensure that your keys are handled by the correct code. That's right. And there are like multiple use cases which can basically which can benefit from TE's integrity and confidentiality. So I think in the previous cases we talked about integrity in the sense that the code can't be changed, and then confidentiality in the sense that the private keys which have been sent can't be leaked outside. Similarly, there are multiple use cases. Like some of the use cases are Telegram sniper bots. Like basically, Telegram sniper bots are, I think, basically you can snipe for trades based on certain news, or and these Telegram bots or these sniper bots, maybe you have written your own code and you want the logic to be private. In such case, or the other scenario can be, maybe you are an app developer who built some sniper bot and you don't want to share the logic with everyone, but you still want to make money by basically you want to provide access uh, to your users, but you don't want to share the code as such. In such cases, TEs are a great way, because if you load the code at runtime, then the code is actually private to the enclave, and you can't, like, users or anyone else, competitors or whoever, can't really access this code. So this essentially helps app developers uh, build code which is confidential and which they don't want to share with everyone, but still ensure that others can use it. Uh, right. So that's essentially some of the uh, things you can build using TEs. Even private computations can be run, and the code can be private completely. Right. And the others are, I think, pretty straightforward. So yeah, I'll probably go with them. Just a second, let me present my screen. Mm, I hope my screen is visible. Oh, else can you like present my screen instead? Can you choose my screen instead? Yep, thanks. Okay, let's go here. Mm, okay, so documentation. Okay, so I think we'll share this with the participants after the workshop. But in our docs, we have a lot of tutorials. I'll probably run you through some of the tutorials. to give a feel of what are the features which are provided and how you can use them in context of your applications. Um, yeah, okay. So yeah, so let's start with the tutorial. I guess you can set up your environment. We have a CLI tool which makes it super easy for anyone to run like these. Essentially, all you need to give, like basically, all you need to make is the Docker Compose file. So, as I said, ours is a Docker-based interface. So, you create a Docker Compose file, and everything runs smoothly beyond that. Okay, let's probably do a quick demo of this. This is just an echo server. It basically echoes whatever you ask it. Once you connect to it, whatever you send, it sends it the same thing back. Uh, so I already copied this into my main.rs. Now, yeah, I'll just probably run it and show you how this works. Uh, So yeah, it just echoes, and you can see here that the connection was made locally, right? So this is how this echo server works. It's just an example. We'll deploy this. I think this is mostly inconsequential. Like you can basically build anything here. It can be your AI agent. It can be anything. And then like how once you have your code ready, once you have your AI agent code ready, then the next thing which needs to be done is the Docker image which you want to run within a TE has to be like pushed to Docker Hub. So you can do Docker login and then push your image. You can build and push your image. So I'll probably do that. Okay, this. Mhm. So we'll build an image and we pushed it to the Docker registry. Right? So once it's pushed to the Docker registry, you can test it by pulling from Docker registry and all, so that to ensure it's working fine. And after that, we, all you have to do is once all your Docker images, which you want to run within the TE, are pushed to the Docker registry, then you need to create a Docker Compose file to define how these services interact with each other. In this case, it's just one service. So you can just like specify image and restart unless stopped, and all these things are like up to the user. So this ensures that the service restarts if it fails for some reason. And then network mode host is actually necessary to run your code within a TE. So network mode host must be specified. Um, this will ensure that networking works as expected. This has to be done for each and every service which you run. So for if you have Echo Service 2, then you essentially have to do something like this. So yeah, let's say I have Echo 2. Yeah. So yeah, you can pass more things, but network mode host is a must. So you can't like yeah, without this the networking won't work. So yeah, once you do this, right. Now once you do this, once you build the Docker Compose file, you can deploy it. And to deploy, we use the Oyster CVM CLI, the CLI which I mentioned at the very beginning. When you set up your dev environment, you essentially install this CLI, and this can be used to deploy. Okay, let's probably deploy one and see. Mhm. It takes a couple of minutes to. So basically, the transactions are paid for. The basically when you deploy a TV instance, the payment is done in USDC. So you would need a tiny amount of ETH on Arbitrum one and some USDC to pay for the instance. We provide credits for the purposes of hackathon. So I'll share a link at the end of the workshop where you can apply for credits, and we'll share some with you so that you can work during the hackathon. Um, and yeah, it's a couple of minutes, so we'll probably run through the other things. Yeah, so next is so this is all it takes to deploy your AI agents to TVs. That's about it. Now, what we'll see next are certain features which you might need. Um, so these are like there are. So I talked about confidential, like basically users being able to share secrets. User like basically you can pass secret environment variables, API keys, it can be your code or anything else. If you want to do that, one of the options is initialization parameters. So basically, when you initialize, when you deploy an enclave, you can initialize the service with with some data, and this data can be completely private. So we send it like basically when you do this, the data is encrypted with the enclave's private key, and then the encrypted data is shared with is basically posted on chain, which is shared to the enclave, and this encrypted data is decrypted within the enclave and consumed by the application. So essentially, this initialization parameters help with that. And all that needs to be done is that um, when we deploy, there is a init params flag which needs to be used. And this essentially, there is a syntax for it, which is enclave path. Enclave path is the path, it should be within the enclave. And just so the path is always prefixed with slash init parameters. So what that means is that if you specify .env here, the absolute path of the file within the enclave will be slash init param slash .env, right? So that's essentially the enclave path. It's all mentioned here, so you don't need to worry about it. Uh, and then attestation. So basically, it is added to the attestation. This essentially helps you differentiate between enclaves. If you have more questions about that, of course, you can reach out to the team and we can help out. But there is documentation on this as well. And then there is encryption. So essentially, setting one here ensures that whatever data you pass is encrypted and sent to the enclave. If you specify zero here, it is not encrypted and is visible to everyone. So yeah, just ensure that you use the appropriate flags based on your the files you pass. So init parameters can pass non-secret things as well as secret stuff. So it all depends on the flag, and you can pass multiple parameters as well. This is just one of them. You can pass like you can just specify init params and pass another file. It will also be sent to the enclave and stored in slash init params. So yep. So this is the enclave is deployed. So we'll just do nc 8080. Yep. Yep. So yeah, it's deployed and it's available. Um, you can even request an attestation, which is the document which I specified. Let me actually use Oyster CLI to verify. Oyster CVM verify minus IP and sorry, it should be answered. Yep. And you can see that the verification is successful. This essentially helps you verify that it's actually an enclave, and there is a attestation which we receive, and then we verify it against the expected. Basically, it's a cryptographically signed document which you receive, and then we verify the document. And these are the various parameters. This is the enclave key, which I'll talk about more right after this. This essentially is a key which is generated within the enclave, and this is the public key of the public key counterpart of the private key which is generated within the enclave. So within the enclave, it's available at a specific location. You can use that to build your applications, and it can be verified, like signatures of it or anything like that can be verified externally by verifying the attestation document and then extracting the public key from it and then using that to verify the signatures. And yeah, these are some other. This is the hash of the user data, which is which is the .ini file or any of the unique parameters which is in. It's the hash of that, and PCR values essentially represent the PCR values along with user data essentially represent the uniqueness of the enclave. So if let's say, which is basically the image ID. The image ID is a hash of user data PCR values. So essentially, image ID is unique to your particular enclave. If someone else deploys exactly same enclave, then it will have the exact same enclave image ID. Okay? So that's yeah, that's the Oyster verify. Now let's go back to this is the initialization parameters I talked about. Let's talk about a few more things. Um, this, so you once you deploy, let's say, generally you can because it's based on Docker. Once you build the Docker image, you can test everything locally. You can ensure that it works, and then push to the TE. Let's say you want to test further. We will be releasing a version tomorrow, which will have a local simulation mode, which you can use to debug any of the issues you might be facing. Uh, and then even without that, like there is a debug mode which is already available. You can launch your enclave in debug mode and then get all the logs. Let me probably do that right now. It will take some time, so we'll probably let it run. Mhm. So we will be deploying the same thing, but in debug mode, and we'll see what happens then. Um, so that's debug mode, and it gives you all the logs of the enclave. But the debug mode, as it specifies, is not a production mode, which means all the verifications which you do. We did a verification here, right? Like Oyster CDN verify. This won't work. This will throw an error if you use a debug mode. That's because you can see all the logs, which means data can be leaked, which basically means it's not a secure mode to run in. That's why all the verifications fail when you run something in debug mode. And this is like just for debugging purposes, and you should never run a production app in debug mode. And yep, that's one thing. You can update deployments. So essentially, when you deploy, as you can see here, we received an IP address, right? And you can update the code which is present on the enclave so that it retains the IP address and redeploys your enclave with new code. So that can be done, and you can do updates to your deployments and ephemeral keys. Okay, so now this is slightly important, and this is something which is can be used in a lot of uh, agents. So essentially, within the enclave, there are keys which are generated. There are two types of keys which are generated. One is ephemeral keys, and the other is persistent keys. As the name suggests, ephemeral keys are keys which are temporary, and once the enclave stops, the keys are lost. So essentially, these sort of act like unique identifiers because the key is generated once the enclave starts up at runtime, which basically ensures that and the randomness is generated at that point. So this basically ensures that the keys, no one has access to the keys, and these keys stay only uh, within the enclaves. So these keys can be used for, let's say, signing to prove that the enclave is actually so basically, if let's say you want to verify a response from the enclave, now how do you know that first of all the response came from the enclave, right? So to do that, what you can do is that the message, the response which is being sent, can be signed with an ephemeral key, and then you can like take this ephemeral key, and then you can get the public key. As we did in verify, you can see that we have the public key here, enclave public key. So you can use this public key, and then you can verify any message which is sent from the enclave. We suggest doing this because though the enclaves are completely secure, but any message you send outside without a secure channel, which basically means just sending a response to a HTTP message, is insecure in general. So essentially, you have to either sign it or encrypt it, depending on the application usage. So that's the ephemeral keys, and the ephemeral keys are available at /app/id.sec. Oh, by the way, yeah. So you can see that this is actually the enclave logs. We'll just run something real quick and see if it's working. Where's where's the IP address? So here's the IP address. Now we'll go here. We'll go and see 8080, and yep, you can see that it's connected, and then it's essentially echoing the same thing. So if you want to debug your application, you can run it in a debug mode, but debug mode is not supposed to be used in production. Right? Yep. So that's the debug mode and the ephemeral keys. The ephemeral keys are available at specific location, and you can access them. But yeah, and these can be used to securely interact with the enclave. And then we have persistent keys. So it's not every application would like some applications would need keys which can be reused. Like let's say you have an AI agent and you generate a key within the enclave, and user transfers funds, and then enclave goes down, right? Then if the key is lost, the user funds will also be lost along with it, right? So in such cases, you need your keys to be persistent, right? So persistent keys are essentially used for that. They enable this functionality where the same enclave can always regenerate the same key, and no other enclave can actually get this key. This can only be requested by the enclave with the same code, same input parameters. So that way you can be sure that someone else can't have access to your keys, right? So that's essentially the persistent keys. And then we have a more advanced version, which is called contract-based access control. Uh, there is a lot of documentation about this, but essentially what this mode enables is that users will be able to update the code. Let's say persistent keys are linked to the enclaves code, right? But let's say I today deployed some version of my bot, like my AI agent, and I found a bug in it, and I want to update it. So when I update it, I want the KMS key, the key which is generated within the persistent key, which is generated, which holds user funds, to be accessible by this updated version of your code base, right? So that's possible to do, but the updates, so basically that can be achieved through contract based access control, where you deploy a contract and the contract specifies what is the correct, or whether a specific uh, enclave can actually receive a KMS key or not. So this is what we mean by contract-based access control. And this is actually useful in a lot of practical scenarios where the developers can't be sure that the code can never be updated. Of course, there needs to be checks and balances to ensure that this is not updated randomly, but that's basically applications can decide how these checks and balances are designed, and all of that is possible. It's completely flexible. Yep, I think these are a few features which I wanted to talk about for this hackathon, like to build AI agents. And these essentially will enable like basically building applications which are actually secure and users can trust them with their funds, or they can even share personal information with them. It can be a personal assistant, or it can be a personal counselor also, because nowadays a lot of people are actually using it to using AI to tell a lot of personal details, and then getting advices or getting uh, yeah, that's and this you can't expect users to do it with a system which where other humans can access it. So I guess TEs are a great way to enable such systems. Um, Alice, can you let's move back to the deck? Thanks. Uh, okay, let's go to the next. So yeah, I think as I said before, but I'll probably run through it again. Uh, how do you build your AI agent? What are the steps you follow? Is are first you build a Docker image. This encapsulating all your code or your logic. But this particular Docker image shouldn't have any of the secret information. It should just have public information. And any secret information should be provided to the TE at runtime. So, which basically means the private data can be sent as init parameters, or if you want to like import code bases, then you can send the URLs or access tokens to this particular code base through the init parameters. So init parameters are used to send a lot of private information, and they should never be part of the initial code which is being deployed, because this is supposed to be public. Then once you have this code, a Docker image which contains your agent code, then you can test locally based using the Docker image you have built. Then you can simulate the environment locally using the simulate command in Oyster CVM CLI. We will. I'll share the documentation regarding this after the workshop. Uh, and then once you simulate and ensure that everything works fine in a TE environment, then you can push your Docker images to the Docker Hub. And once you push to the Docker Hub, you are ready to go. You can deploy your your code or AI agent within a TE, and you can even pass private information once the TE starts, or as init parameters, right? So yeah, I already showed how to use init parameters, and it's all available in our docs, and we are anyways there to help. Yeah. And the next is attestations. I think we have talked about this. This essentially, yep, where is that? Yes, the verify. Yes. So Oyster CVM verify. This essentially verifies the attestation. It prints out all the information. It prints out the image ID, which is the unique ID of which combines your code. Like it basically is a fingerprint of all the code which is present within the TE, and based on this, you can prove to anyone else that you have used the same code which is expected to be used, and you haven't added any backdoors or anything which can leak data, right? So that's, and I guess these are some things which we have already seen in our documentation. Essentially, Oyster's CVM is the command line tool which can be used to simulate local environments. It can be used to deploy in debug mode and production mode, and these are just commands to do that. And these are the resources. There are like very detailed docs available. You have tutorials which if you run through the tutorials, and it shouldn't take a long time to run through it, probably an hour or two. And once you run through the tutorials, you should be able to like build your applications and use Oyster to deploy your AI agents within a team. And for the sake of the hackathon, we have a form which I'm going to share with Alice after the workshop. You can fill this form to get credits. So basically, we'll send you the USDC and ETH, which is needed for you to run like deploy TEs on Oyster, on Marlin TEs. Okay, and then we have a Discord link, and we'll also be sharing all this information in the Telegram group so that you guys have access. And we are very active in our Discord, so you guys can drop there and then ask us any questions you might have. And yep, that's about it. Hope you had a great hackathon and build something cool. Yep. Else, that's it from me.
Awesome. That was rad, Pratik. That actually covered a lot more than I would say a lot of the different workshops and many of the different AI agent events that we have hosted actually cover, from getting started all the way through to deployment. So thank you very much for that. And guys, like Pratik had said, we are going to be not only uploading this workshop for you to watch whenever you want to, but you can access the quick start links, you can access the Marlin docs and any other types of information that you need on either the Hacker Earth microsite or straight in the Telegram, and we can kind of help you out as we go. Separate to that, there is always time to schedule mentor workshops or one-on-ones with the Cracked Labs, Marlin, Aptos, Eliza OS teams. So be sure that if you have any questions while you're on Telegram, do not be scared to DM an admin. We are here 24/7. We are here to help, and we want to actually help you get live, hear your pitch, hear what this agent can do, and try to break the internet at the same time. Right. So with that, guys, a big thank you to Pratik. Pratik, again, awesome workshop. Very stoked to have Marlin on board. And everybody, stay tuned. We have another workshop coming up in about an hour. That one's going to be about building predictive DeFi agents with a LoRa network. So stay tuned. Again, thanks again, Pratik.
Yeah, thanks, Alice.
Thanks, everybody.
Bust the deal. Face the wheel.